Hey, 12th graders. So we are moving on in our very small Unit 12 unit about sinusoidal modeling. We learned last time about all the different key behaviors of trigonometric models, your amplitude, which is from halfway of your graph, right? Your amplitude is the top height and the bottom height, right? It's your total height divided by 2 is your amplitude. Not a very good explanation, sorry. Your period is how long it takes to complete one cycle. So the distance from maximum to maximum or the distance from minimum to minimum. We always look at our x-axis to determine the period, whereas amplitude is on your y-axis. And then you've talked about your principal axis, which is this last number right here. And it's the number that's in the middle horizontally, right? So it's the number that you're like zigzagging across. And again, that's a y value that we look at. So that's what we talked about last time. And now, as I'm sure you're starting to see, we've got some unknowns going on in these trigonometric models. So this second lesson of this unit is all about like getting started with creating the models. So keeping in mind what these three key behaviors of trigonometric models mean and where they are in the equation will be incredibly helpful. And also keeping in mind how we solve for unknowns. So let's just first talk about how we solve for missing values. So we have kind of two ideas. The first one is just when we have one unknown. With one unknown, we only need one piece of information, right? Thinking about our systems of equations, solving for systems of equations, if we have two unknowns, we need two pieces of information, two equations, right? If we only have one unknown, we only need one piece of information. And what you do with that one piece of information is you put it into the equation, right? You plug in your x value for x, your y value for y, and then you solve for the other unknown that's in there. Your piece of information is often just a point. One piece of information to plug in and solve. So then, when we have more unknowns, like two unknowns, we would then need two pieces of information. When we have two pieces of information, we can then create two separate equations, and that's when we have a system of equations. And this works for two or more unknowns, right? Three unknowns means we have three pieces of information, three equations, three ideas, right? And so it's two or more pieces of information. And this is then to make a system of equations. Right? So one unknown, you just need to grab one point or one piece of information and just solve for the unknown. Two or more unknowns means that you're making a system of equations. So just keep that in mind as we're going forth and solving for missing pieces of these trigonometric equations. Our first example, IB example, a swing at a playground is released from its maximum height above the ground. The height h meters of the swing above the ground at time t seconds after the release can be modeled by the equation h equals, and then we've been given an equation. Notice that we have b times t. Our input is t, time, seconds, right? Our output is h. So we have an unknown in this equation. We don't know what that is. So a good strategy when you see that in the equation is if there is an unknown, circle it and put question mark, right? Like, or something to signify that you need to solve for that. Another strategy to be using when you're talking about an applications problem is just take a second and ground yourself in the problem. What is the story of this question? What are we talking about here? What would this look like as a graph? There's a lot of things that we can think about in order to like kind of first step into the story that is this problem. Since it is an applications class, there's always a story, and it will help you to be able to kind of problem solve and put pieces together if you understand the story of the problem. So we got a swing, we're going back and forth. And so talking about height over time, we're talking about as time goes on, what has my height been doing? And so we probably start off with going up and then down and then up and then down, right? Is kind of the idea at time versus height. Okay. And I know that it's like some sort of trigonometric thing. Technically, when we have cosine, it starts at a maximum or starts at a minimum. Only sine starts halfway through, but we can talk about that at a different time. And then we are given some pieces of information. And so keeping in mind what this information means, 1.1 is my principal axis, right? It is my value that goes smack dab through the middle. So this would be like y equals 1.1. That is given to me. So I know that that's going to be something that's going on. And then my amplitude is 0.58, which means I go up by 0.58 and I go down by 0.58. So, okay, my maximums occur above by 0.58 and my minimums occur below by 0.58. So, when it moves on to the problem and says, okay, find the maximum height, find the minimum height, you don't actually need to have B in order to solve for those things because in the equation, the parts that you already have, you already know how to solve for that, right? And so taking a second to ground yourself in the problem and be like, what does this mean? What do these parts of the equation mean? Can I solve for any of these pieces? You can do this very easily. These would be 2 marks, like they should be quick, right? The maximum height would be 1.1 plus 0.58 because I've gone up my amplitude of 0.58. Which is 1.68 meters, right? So the minimum height then would be that 1.1 minus 0.58, which is 0.52. Okay, so a common mistake would be that students are like, well, I can't graph this equation, so I can't find what the maximum height is. I can't find what the minimum height is because I'm missing this variable. If you ever run into that in a problem where you're like, well, what I would normally do is I would graph this and go and find that, but I can't because there's unknown variable. I have multiple inputs now going on. I don't have all the information I need in order to solve this. The information is there. They haven't asked you to do it without giving you the information that you need. And so you need to think about, well, what is the information that I've been given? What do I know about this? And if you take a moment to kind of like insert yourself into the equation, you might have already done the thing that you need to do in order to solve for those equations by first trying to understand what you do have, right? So just keeping that in mind that this is a common thing. People will get stuck because they don't have that input. Well, you don't need that input in order to solve that equation. You need to know what these different pieces that you have mean in order to use them correctly. Then it says the swing takes 0.6 seconds to move from its highest point to its lowest point. So I'm going back to the graph that I made to try and like visually understand what's going on. To go from the highest point to the lowest point was a distance of 6 seconds. And then it said find B. Okay, well, B is this value in here that I use to find what? What is B associated with? What key behavior is B associated with? B is associated with your period, right? The period is equal to 360 divided by B. Well, by giving us that it takes 0.6 seconds to move from the highest point to the lowest point, 0.6 seconds, then in order to make it again to the highest point, it would be another 0.6 seconds, which means that my entire period would be 1.2. So going back to that information about what I know about the period, well, the period is 1.2, and that's equal to 360 divided by B. From here, you can solve for B. And go ahead and do that on your own. You could either put this into numerical solve or multiply by B and then divide by 1.2, or put this over 1, cross multiply and solve. Either way, you would get that B is equal to 300. Now that you have all this information, you can go ahead and solve for C, strategy for tests. You need to have B solved in order to solve for like plugging in a value for T, right? H is equal to 0.58 cosine of 300t plus 1.1. Well, if you didn't have B being 300, then you couldn't solve for this. But also realize the IB is trying to help you here by making it a separate question, right? They're saying, hey, solve for B, and whatever you get for B, as long as you plug that into this equation and then also plug in 4 for T, you get follow through points, right? So just keep that in mind. If you're stuck on solving for B, circle it, put B equals something. Don't just move on and make something up in C. You have to take the thing that you got in B and plug it into the equation in the next part for you to get follow through points. So the strategy here is that you should be putting down something, B equals something, and then use that value below so you can get credit for what you do know how to do, which is that you just need to plug in the value you got for B. And then if T equals 4, H equals question mark, okay, then H equals 0.58 cosine of 300 times 4 plus 1.1. If you put that all together, it equals exactly 0.81 meters. So after 4 seconds, you have swung up to 0.81 meters. Okay. So this is kind of our first entry level into making a model, right? It's mostly been made for us. We just have one variable that's missing. When we have one unknown, all you need is one piece of information in order to solve for that unknown. Now, you don't need a complete equation in order to solve for some things in this situation, like amplitude and height. All come together. You don't need to know anything about the period in order to solve the maximums and the minimums, but you do need to know in order to have a complete equation in order to evaluate things that involve time. So we had to solve for B and then use that to come together to one full equation. Classic, straightforward, quote unquote, easier of the modeling sinusoidal questions. Now, example 2 shows us something slightly different, a little bit harder, because notice that now we have two unknowns. When we have two unknowns, we need two separate pieces of information, which means we're going to have two separate equations. We're talking about now systems of equations when we have more than one unknown. Our unknown is A, and our unknown is D. X is our input, f of x is our output. And notice in this graph, we have 2 points. 2 points is two pieces of information, which means we can make two equations. So all I need to do is plug in these points and make my system of equations. That's it. So the thought process is one unknown. I just need one piece of information, just plug it in and solve. Whereas when you have more than one unknown, two or more, you need to make systems of equations.